Hello everyone. Good afternoon to all of you. Very good afternoon, students. Please let me know whether I'm audible and visible or not. Can you all able to see the screen? Can you all able to hear my voice? Can you all able to see me? Okay. Okay, I'll try to speak little bit louder. Is it okay? Episaka? Is it okay now? Am I not audible? Okay. Okay, fine. So, how is my voice now? Can you all able to hear my voice properly now? Is it still low? Yes, Fatima too. Good afternoon. Still it is very less. Is it still very low? Wait for some time. What is the issue? Yes, Sri Lakshmi, good afternoon. Okay. So we are dealing with the equilibrium concept, right? So chemical equilibrium concepts have been covered yesterday, and I said today we are going to see the ionic equilibrium, right? So yesterday we have solved some 2 to 3 questions from chemical equilibrium, right? So today I have got some more questions, some more previous year question for you. So we will try to do those, like 4 to 5 questions are there. So we will cover that and then we will move on to the ionic equilibrium. Okay, is that all right for everyone? Is my voice okay? Audible now? Yes. Okay, great. So now we will go ahead. Thank you so much, students, for your responses. Now we will go ahead with the previous year question. And here is the question. So this is a question from, is it still very low for all of you? Is my voice still very low for all of you? Or it is only for this ones? Okay, okay. Okay, my dear. So let's solve this question together. So for the reaction SO2 plus half O2 giving SO3, Kp is equal to 2 into 10 to the power 12 at 27 degrees Celsius and 1 atmospheric pressure. Okay. The Kc for the same reaction is dash into 10 to the power 13 and R value is given. So we don't have any options for this question. Okay, means this is a question from JEE Mains. Got it? If this question would be a NEET question, then we would have had options, right? So this is a JEE question, numerical based question. So we have to find out the number which will come in the dash. All right. So how to solve this? What is given in the question? We have the Kp value in the question. Okay. And also the temperature, 27 degrees Celsius. And also the pressure. We are asked to find out the Kc. So how to find out the Kc? Using Kp-Kc relationship. Okay. So we know that Kp is equal to Kc into RT power delta Ng. Okay. So we have the value of Kp, which is 2 into 10 to the power 12, which is equal to Kc. And R value is given as 0.082 into the temperature. Temperature is 27 degrees Celsius, but we have to convert it into Kelvin. Okay, so how to convert 27 degrees Celsius to Kelvin? So you have to add 273 to 27 to get the answer in terms of Kelvin. So it will be 300. Okay, so the temperature is 300 Kelvin and we are asked to find out the delta Ng. So how to find out the delta Ng? It is equal to number of moles of gaseous product minus number of moles of gaseous reactant. Number of moles of gaseous product minus number of moles of gaseous reactant. Students, is my voice still low for all of you? Ishrat is saying it is not audible at all. Am I not audible? It is audible and it is clear, right? Yeah. Okay. Okay then. Ishrat, just check your network connection now. Okay, we will go ahead. So have you find out the value of delta Ng for this question? Has anyone got the answer of delta Ng? How to find out? The number of moles of gaseous product. So SO3 is the product and its number of moles is 1. And what about the reactant? We have two reactants and both of them are gases. So SO2 is 1 mole and O2 is half mole. So it will be 1 plus half, which is 1.5. Okay, very good, very good. It is 1.5. So it will be 3 by 2. Okay, so 1 minus 3 by 2 will be equal to minus 1 by 2. So that is the value of delta Ng. Okay, so after substituting and after the multiplication and the division process, we will get the value of Kc as 9.92 into 10 to the power 12. Okay, but we have to find out the answer in terms of 10 to the power 13. Got it? So what we have to do? I have to move the decimal. So to which side I have to move the decimal to increase the power of 10? Now I have to increase the power from 12 to 13, right? So it is moving towards positive direction. So I have to move the decimal place towards left side. Okay. So it will be 0.992 into 10 to the power 13. Okay. Now we have to find out the answer in nearest integer. Okay, the nearest integer has to be given. So 0.9 can be approximated to 1. So it will be 1 into 10 to the power 13. Okay, very good, Rakshita. Your answer is correct. So the answer is 1. So it is 1 into 10 to the power 13. Is it clear for all of you? You just have to spend some time in doing the multiplication and division. Rest all will be easy only. Okay, just the direct substitution into the formula only. You don't have to worry much about this question. All right. Is it clear for all of you? I hope all of you are doing the answers in your notebook. Yes or no? Yes. All of you, please have the notebook with you. Have the pen and pencil with you. And all of you have to try the answers in your notebook. Okay, otherwise it will be a waste of time for you. Got it? I know all of you will be doing it. And if anybody is not doing, please don't waste your time just listening the class. Take your notebook and try to solve the question and try to give me the answer. Okay, if you have completed. So, shall we go ahead with the next question? Any doubt from this? Fatimatu, Ajmala, you guys are new or what? Today only I am seeing the names of few people. You guys have joined today only? Many of you are new, no? Farnas. Okay, okay. Okay, dear students. So try to attend the classes every day. Got it? So don't skip the class. If you skip the class, you will miss the concept. Okay, then it will be very difficult for you to follow the class. So please don't miss the class. We'll go ahead with the next question. So this is question number 2 for today. The question says that 4.5 moles of each of hydrogen and iodine is heated in a sealed 10-liter vessel. Okay, it is heated in a sealed 10-liter vessel. At equilibrium, 3 moles of HI were found. The equilibrium constant for H2 plus I2 giving to HI reaction is. So we are asked to find out the equilibrium constant. So what it is? It is Kc. We have to find out the Kc. Okay. So let me write the reaction. It is H2 plus I2, which is in equilibrium with 2HI. Okay. Initially at time t is equal to 0, initially how many moles we have? We have 4.5 moles each of hydrogen and iodine. So, hydrogen mole is also 4.5 and iodine is also 4.3. Got it? Initially, there won't be any formation of product. Okay, so we won't be having any amount of HI in the beginning at time t is equal to 0. But at equilibrium, what is happening? At equilibrium, the 3 moles of HI is found. How many moles of HI were found? 3 moles of HI were found. 3 moles of HI were found means 3 moles of H2 and 3 moles of I2 would have been reacted. Then only 3 moles of HI might have produced, might have formed, right? So at equilibrium concentration, the concentration of H2, I2, HI, everything is going to be 3. Okay. So now the Kc for this reaction can be written as, how to write the Kc, students? It is the product's concentration raised to the stoichiometric coefficient divided by the reactant's concentration. H2 and I2 are the reactants and its stoichiometric coefficient is 1, 1 each. Okay. This is Kc. So now what you do? These are the equilibrium concentration values. So substitute the values here. HI concentration is 3, but we have square, and H2 concentration is 3 and I2 concentration is also 3. So 3 square is 9 and 3 into 3 is 9. So the answer is 1. So the Kc value for this reaction is 1. Okay. So again the answer is coming out to be 1 for this question also. Clear for all of you? Able to understand? Shall we go for the next question, students? Very good. What about others? Yeah. Okay, let's go for the next question. So if you want some time to copy the question or the answers or the explanation, you can tell me. Okay, I will wait for some time. During that time, you can copy the answers or the explanation which is there on the slide. Then we can go for the next question also. Okay. So don't feel shy. Don't get scared. Okay. To ask something or to tell something. So I'll go for the next question. Consider the following equation. Again, we have the sulfur dioxide reacting with oxygen to give sulfur trioxide reaction. And the delta H for this reaction is minus 190 kilojoule. Okay. So delta H is minus. So what does this negative sign indicates? This negative sign indicates exothermic reaction or endothermic reaction. Can anyone tell me? What is the name of the reaction? If delta H is given in terms of minus, is it exothermic or endothermic? Very good, Roshan. Very good, very good. Super. It is exothermic. So delta H denotes that the reaction is exothermic in nature. Okay, exothermic means heat energy will be released. Now we have to find out the number of factors which will increase the yield of SO3 at equilibrium from the following. So we have to find out the factors which will increase the amount of SO3 gas produced. Okay, so how to find out? The first factor is increasing the temperature. So yesterday, when I am discussing the factors affecting the Lee-Chatelain's principle, I have discussed about some 5 to 6 factors, right? Changing the temperature, changing the concentration, changing the pressure, addition of inert gas, addition of catalyst, right? Increasing addition of reactants, addition of products. So we have discussed all the things yesterday. If you have revised yesterday's class, you can give the answer for this question. Can you tell me? Okay, let's go one by one. We will do this question together. We'll go one by one. We'll take the first one. Tell me whether the amount of product will increase on increasing the temperature or not. Reaction is exothermic. Reaction is exothermic. For exothermic reaction, if I increase the temperature, what will happen? Yesterday I told you, right? Increasing the temperature means I'm giving the heat to the system. Okay, exothermic means the heat energy will be released. So, even if I increase the temperature of the reactant, the heat is going to get released only. It is not going to increase the amount of the product. It is not going to increase the amount of the product, right? So, for exothermic reaction, even after increasing the temperature also, the amount of the product will not get increased. Yeah, very good. So backward reaction occurs, right? So that is not correct. It will not increase the product. So this factor will not increase the product. Okay. So now we will go for the second one. Increasing the pressure. What do you say about this? Increasing the pressure. So I am having a container and the SO2 gas and O2 gases are here. If I increase the pressure, what will happen? The reaction will move towards forward direction. If it moves towards forward direction, what will happen? More amount of the product will be formed. More amount of the product will be formed, right? So we will get the more amount of SO3 and it leads to the increase in the yield of SO3. Clear? So increasing the pressure will increase the product for exothermic reaction. Okay. And what about the third one? Adding more SO2. SO2 is one of the reactant. So this is actually increasing the concentration of the reactant. The first factor which we have discussed yesterday. Increasing the concentration. So if you increase the concentration of the reactant, what will happen? Reaction will move towards forward direction. Yeah, very good. It will move towards forward direction. If it is moving towards forward direction, obviously the sulfur dioxide yield will be more. Right? So, adding more SO2 will increase the product of SO3. And what about the O2? O2 is also this reactant only. So, if you increase the concentration of O2, again, the reaction will move towards forward direction and the amount of SO3 will increase. Okay. What about the last one? Addition of catalyst. Yesterday we have discussed, right? Addition of catalyst. Addition of catalyst will affect the yield or it will not affect. Very good. There is no shift. Very good, Rakshita and Roshan. So, adding a catalyst to the system will not increase or decrease, or the reaction will not go towards forward direction or backward direction. It will just reduce the time of the reaction in which it is taking place. Okay. So it is not going to affect the yield. So addition of catalyst has no effect. So how many factors increase the yield of SO3? 3 factors. So the answer is 3. Okay. So this is again a numerical type question. The answer is 3. So this is how you have to apply the concepts which we are learning in the theory part of the lessons. Got it? So you will get to know the application oriented skill only if you solve some questions. So that's why I'm taking time and solving the questions from the chemical equilibrium. Okay. Just learning the theory alone and memorizing the theory alone will not help us to crack the JEE and NEET examinations. Got it? To get good marks, you need to practice more number of questions. Okay. So is it clear for all of you? Do you have any doubts from this question? Shall I go for the next question? Shall I go for the next question, students? Okay. Okay. If you have not attended the yesterday's class, so some people are new today, right? So if you guys have not attended, if you do not know what I have taught yesterday, I already told some people, we have a YouTube channel, Avanti Live 2. If you go to that channel, you can find the yesterday's class recording. You can go through that. Got it? So now we will go to, yeah. So now we will go to the next question. Yeah, this is similar to one of the questions which we have discussed yesterday. Do you guys remember? The people who have attended yesterday's class, do you guys remember? We have solved a similar type of question yesterday, no? Same reactions, same reactions. And the desired equation is also same. Can you tell me what is the new equilibrium constant we got yesterday? What is the new equilibrium? Or what is the equilibrium constant for this desired equation? The KEQ will be equal to, so we have reversed this first equation, right? So we have got 1 by K1 and we did not touch this K2. And we have multiplied this third equation by 3. So it was K3 cube. So we have added all the 3 and we got 1 by K1 into K2 into K3 cube, right? So this is the new equilibrium constant. So I am writing that here, but we have to find the answer here in terms of number. Because in the yesterday's question, we did not have any values for K1, K2, K3. Okay, but in this question, we have got some values. We have to substitute those values here and then we have to find out the answer in terms of 10 to the power minus 30 for the desired equation. Okay, we have to find out the equilibrium constant, Kc or Keq, anything we can keep. So what it is? So we have 1 by K1 and in the numerator I have K2. So K2 value is 1.6 into 10 to the power 12 and K3 is 1 into 10 to the power minus 13 the whole cube divided by K1, which is 4 into 10 to the power 5. So can you guys solve this? Answer is 4. Very good. So it will be 1.6 into 10 to the power 12. And if you multiply this by 3, you will have 1 into 10 to the power minus 39 divided by 4 into 10 to the power 5. Okay. If you solve this, you will get 0.4 into 10 to the power minus 32. But to get the answer in terms of 10 to the power minus 33, minus 32 to minus 33. So I am moving towards the negative side. If I'm moving towards the negative side, I have to move the decimal towards the right side. Okay. If I'm moving towards the positive side, you have to move the decimal to left side. If I'm moving towards the negative part, then I have to move the decimal to the right side. Okay. So I will get the answer. So it will be equal to 4 into 10 to the power minus 33. So the answer is 4. Answer is 4. Clear for all? Shall we go for the next? Shall we go for the next question? So we have written the equilibrium constant for the decide equation. So if you want to know how I have arrived at this 1 by K1, K2 and K3 cube, please go through yesterday's class from the YouTube, okay? So there I have explained. So now I will go for the next question. Consider the following reaction approaching equilibrium at 27 degrees Celsius and 1 atm pressure. The reaction is given, rate constant for forward reaction and the reverse reaction is given. The standard Gibbs energy change at the same 27 degrees Celsius is minus dash kilojoule per mole. R value and logarithmic function log 10 value, ln 10 value is given. So we have to find out delta GR. What is the formula to find out the delta GR naught, students? What is delta GR naught? Can anyone tell me in terms of LN? What is the formula to find out delta GR naught? You guys remember the formula? Not in terms of log. You have to give me the answer in terms of LN. Shall we go ahead? So not even a single student have revised the formula. Huh? Yeah. Okay. Very good, Roshan, but you have missed the negative sign, it seems. Rakshita has given the correct answer. Very good. It is minus RT LN KEQ. Okay. So we have the value of R, we have the value of T, but we don't have the value of KE. So we have to find out KEQ, right? So KEQ, equilibrium constant, is equal to the forward reaction by the rate constant of backward reaction. I have given this expression in the first class or the second class, I think. Okay, in the first session or the second session of chemical equilibrium, you can find this. So just substitute Kf is 10 power 3 and Kb. Kb means backward reaction, or backward reaction is also called as reverse reaction. Kb or Kr, anything you can use. And the value is 10 to the power 2. And it will be equal to, so it will be equal to 10. So KEQ is equal to 10. So now you substitute all the values in the formula. Delta GR naught is equal to minus R into T ln KEQ value is 10. Okay. So what is R value? 8 minus 8.3 into the temperature. Temperature has to be given in terms of Kelvin. Okay, because we are substituting the value of R in terms of joule per Kelvin, right? So convert this to Kelvin, 27 plus 2, 73. So it will be 300 into ln 10 and value is given in the question. So it is 2.3. So can anyone multiply and give me the answer? Can anyone multiply this and give me the answer with the kilojoule per mole? You have to give me the answer in terms of kilojoule per mole. What is 8.3 into 300 into 2.3? Find out fast. Find out fast. No single answer. Okay. Yes, you are correct, Roshan. So the answer will be minus 5.7 kilojoule per mole. Okay. But we need the nearest integer. Answer in terms of nearest integer. So if you approximate this, 5.7 can be written as 6. So it is minus 6 kilojoule per mole. Okay. Delta G R naught is equal to minus 6 kilojoule per. Yeah. Very good, Sanjana. Exactly the correct answer you have given. So have you all got this? Minus 6 as the answer for this question. Are you all doing the multiplication? Are you all doing the multiplication? One minute. Rakshita need 1 minute. Okay. Rakshita, shall I go ahead? Have you completed? Yes, Sanjana. The correct answer is minus 5.7. The approximate value is minus 6. Over? Okay, my dear. So I'll go for the next question. Yeah. No problem, no issues. You can feel free to stop me anywhere. I will stop. Okay. Here is the question. This is the last question. Okay, last question from chemical equilibrium for today. So try to solve this. At 298 Kelvin, the equilibrium constant is 2 into 10 to the power 15 for the given reaction. Okay, equilibrium constant means the Kc value is given for the first reaction. What is the Kc value? What is the Kc value for the given reaction? So what to do? We have to find out the value of x in 10 to the power minus 8. How to get it? What is the difference between the first reaction and the second reaction? What is the difference between the first reaction and how to get the second reaction from the first reaction? How to get the second reaction from the first reaction? So for the first reaction, K value is given as 2 into 10 to the power 15. Okay. In the first reaction, we have copper Ag plus in the left hand side. But in the second reaction, we have, yeah, we can divide it. Will you divide this by 2? No, my dear, you can divide this by 2. But before dividing, you have to check the copper and Ag plus are in the reactant side for the first reaction. But for the second reaction, they are in the product side. The copper metal and the Ag plus are there in the product side. So what I have to do? I have to reverse this first equation first of all. Okay. So if I reverse this equation, I will get copper 2 plus 2 Ag, which is in equilibrium with copper and 2 Ag plus. Okay. So now I have copper 2 plus Ag in the left hand side. and copper and Ag plus in the right hand side. So since I have reversed this equation, the equilibrium constant for this reaction now has to be reversed. K dash will be equal to 1 by K. Okay. But I did not get the second reaction. In the second reaction, I have half 1 by 2 moles of copper 2 plus, but here I have 1 mole. So I have to divide the entire equation by 2. So if I divide this entire equation by 2, what I will get? I will get 1 by 2 moles of copper 2 plus, and the 2 will get cancelled. So only 1 mole of Ag will remain, and I have 1/2 mole of copper and Ag plus. Okay, this is the next equation. So since I have divided the equation by the number 2, or I can say I have multiplied this equation by the number 1 by 2 divided by 2, or I have multiplied this equation by 1 by 2. I can say this in this way also, right? So what is the property we have studied? If we are multiplying the equation by any number, then it has to go to the power. It has to go to the power of the old equilibrium constant. So this is the equation or equilibrium constant relation now. So now that 1 by 2 has to go to the power of this K. Has to go to the power of this K. So this is the new equilibrium constant for this second reaction. Okay, so now substitute. K dash is equal to 1 by K. K value is 2 into 10 to the power 15. So the whole power 1 by 2. 1 by 2 means it is root of 2 into 10 to the power 15. Okay. So if I take it outside, I will get, has anyone solved this? We have to get the answer with the 10 to the power minus 8. So have you solved? Has anyone solved? Has anyone solved? So we will be having 2.23 into 10 to the power minus 8. Okay, and the approximated value will be 2 into 10 to the power minus 8. So you sit and solve and check whether you are getting the answer or not. You should get this value. Okay, so answer will be 2. The x value is 2. All right. Any doubt? Any doubt from today's session? From the today's PYQs? Shall we go for the next topic? I'm really sorry. Do you guys have any doubt from this question? Okay. If you take this out of the root, you can convert this, no? See, this is, this is actually root of 2 into 10 to the power 15. Okay. If I want to increase the power to 16, okay, 16 means I am going towards positive side. If I am moving towards positive side, then what I have to do? Do I need to bring the decimal to left side or right side? The last question I told you, right? Do I need to bring the decimal towards left side or right side? What I have told. If I am increasing the power, then to which direction I have to bring the decimal? Towards left or right? No, towards left. Okay. If I'm going to negative, then only it is right. If I'm going towards positive direction, then I have to go to left side. Very good. So if I'm going towards left, then I can write this as 0.2. So decimal is here. I have to move towards left. 0.2 into I can write 10 to the power 16. Okay. If I take 10 to the power 16 out of the root, I will have 10 to the power 8. Okay, it will be 10 to the power 8. And everything is here in the denominator, right? So if it goes to the numerator, I will get 10 to the power minus 8. I will get 10 to the power minus 8. Got it? Then I can multiply and divide by 10. And I can make this decimal to again 2. Okay, 20. And if I take 20 out of the root, I will get one number. So using those calculations, you can get the answer as 2. 2.23 into 10 to the power minus 8. Okay. Yeah. So the next topic is ionic equilibrium and pH of the solution. So this is the second half of this lesson. All right. The learning objectives under this particular topic are electrolytes, acid-base theories, self-ionization of water, pH of different combinations of acids and bases, and at last, the common ion effect. So these are the topics we are going to cover in the first topic of ionic equilibrium. Okay, so let me start with the electrolytes. What are electrolytes? Actually, the substances are classified into two. Okay, there are two types of substances. One is called as electrolytes and the other one is called as non-electrolyte. So we should understand the difference between these two, right? Then only we can go for the next. So what are electrolytes? Electrolytes are the substances which dissociates in corresponding ions on dissolving in water. Okay. So if I'm saying that a particular substance is an electrolyte, then it means if I put that substance into some solvent, it will get dissociated. Okay. Since they are getting dissociated and they are producing the ions. Producing the ions means they will produce cation and anion. Mostly ions, what they will do? They will conduct the electricity in the aqueous solution. So electrolytes will get dissociated in the solution and that solution conducts electricity. Electrolytes will conduct electricity when they are in the aqueous form. Okay, I will give you some examples. So here are some examples. Sodium hydroxide, HCl, hydrogen chloride, sodium chloride. So I will take NaOH as an example and I'll show you how it is getting dissociated when I put this in water. Okay. So you see here, I have taken the sodium hydroxide and I have added this with X moles of water. So if I put this inside the water, the solution is producing sodium plus ion and hydroxide ion, Na plus ion and OH minus ion. So this is the cation and this is the anion. So all of them are in the aqueous solution now. So they will conduct the electricity. Okay. And coming to non-electrolytes, it is the opposite of electrolytes, right? So if electrolytes conducts electricity, non-electrolytes will not conduct electricity. Non-electrolytes does not conduct electricity. What is the meaning? If it is not conducting the electricity means it is not getting dissociated. Okay, when it is dissolved in water. It is not getting dissociated when it is dissolved in water. So it do not dissociate on dissolving in water. Okay, examples are sugar, urea, etc. So the formula for sugar is C12H22O11. Okay, many types of sugars are there. And the formula for urea is NH2CONH2. Okay, so this is urea. You see here, this is urea. If I add this urea to X moles of water, it is not producing any cation or anion. The substance remains same. The substance remains same. Here it is in the solid form, but here it is in the aqueous form. That is the only difference. It is not producing any cation or anion. Okay. So urea is an example for non-electrolyte. Clear for all of you? If you are getting ions, it will conduct electricity. If you are not getting an ions, it will not conduct electricity. So electrolytes will conduct electricity and they will get dissociated on dissolving in water and they will produce cation and anion. Is that okay? Any doubt? Shall I go for the types of electrolytes now? So first of all, you need to understand that substances are classified into two, electrolyte and non-electrolyte. So now I will go for the more explanation about the electrolytes. Shall I go? Any doubt here? Shall we proceed? Students, are you all here? Okay. So now let me go for the types of electrolytes. Okay. Electrolytes are again classified into two, strong electrolytes and weak electrolytes. Strong electrolytes means dissociation will happen completely. This is very, very important. Okay. What is meant by strong electrolyte? The substances which gets dissociated completely on dissolving in water is called as strong electrolyte. Okay. Degree of dissociation, which is called as alpha, is approximately equal to 1 for strong electrolyte. So examples are NaOH, HCl, NaCl, etc. Okay, and the dissociation almost reaches to completion. So there is no equilibrium exists. So if I take NaOH reaction again, so you see here, NaOH will get completely dissociated into Na plus and OH minus. Okay, so complete dissociation. Na plus and OH minus cannot come back again to form NaOH. So the backward reaction is not possible. So that's why you can see the arrow. This is not an equilibrium arrow, right? So this arrow shows only the forward reaction will happen. Got it? So the dissociation almost reaches to completion and they cannot revert back. So no equilibrium exists for strong electrolyte. But in case of weak electrolyte, we have partial dissociation. Weak electrolytes dissociates partially on dissolving in water. Partial dissociation means the degree of dissociation alpha will be less than 1. Each and every point is very important. So please write this in your notebook, okay? The degree of dissociation will be less than 1. And examples are NH4OH, ammonium hydroxide, and C2H5COOH. This is called as propanoic acid. COOH containing acids are weak acids. So that's why it is coming under weak electrolytes. And NH4OH is a weak base. Okay. So partial dissociation of substance occurs. Hence, there will be an ionic equilibrium. There will be an ionic equilibrium. So for example, if I put the sodium hydroxide into the water, it is producing NH4 plus and OH minus ions. But the dissociation between the NH4 and the OH minus, it has happened partially. Partial dissociation means still there is some interaction between the NH4 plus ion and the OH minus ion. Still there is some force of attraction. So what they will do, the cation and anion will again come together and they will form the reactant back again. So the reaction is in equilibrium. The rate of the forward reaction and the rate of the reverse reaction will be equal. Got it? So this is all about strong and weak electrolytes. So in strong electrolytes, a strong acid, strong base, HCl is a strong acid, NaOH is a strong base, NaCl is a strong acid base containing salt. So all this will come under strong electrolyte. Weak electrolyte means weak base. NH4OH is a weak base, and this compound is a weak acid. So all weak acid, weak base, weak acid base containing salt, all will fall under this category. Got it? So I will explain you what is a strong acid, strong base, and those things and all in the upcoming topics. Okay, don't worry. So you may be thinking like, ma'am, what is a strong acid and how? When do we call a compound as a strong acid, strong base, a weak acid, weak base and all? So don't worry. We have a set of acid-base theories. So that I will discuss once I complete this electrolytes topic. Okay. So any doubts so far from the types of electrolytes and from the types of substances for anyone? Shall we go for the definition for electrolytes now? Okay. So now we will go to the definition for electrolytes. Okay, these are the types of electrolytes, right? So now I will go to the definition. Yeah. And electrolyte is a chemical compound that dissociates into ions. What is the first point? It is a chemical compound that dissociates into ions and is capable of conducting electricity. This is the second point. Capable of conducting electricity. Got it? So the electrolytes can be an acid, it can be bases, and the electrolyte can be the salts. Okay? So we have three different types of electrolytes: acids, bases, and salts. If any one of these dissociates into ions, and if it is conducting the electricity, we call them as electrolytes. Okay. So shall we go for the definition for acids? Shall I start with acid? Are you all ready? So we have some 2 more minutes, right? So shall I go for the acids? Yeah. Acids. So acid, it is derived from a Latin word acidus, meaning a sour. The sour taste containing compounds are acids. So we have vinegar in our home, right? We have vinegar. If you try to taste that vinegar, don't taste the vinegar. If you taste it, you will have the sour taste. Okay. So all the acids will have the sour taste. And that's why from the name, from the Latin word acidus, we have got acid as the term. So if an acid is reacting with the metal, it will produce a salt and hydrogen gas. If an acid is reacting with the metal, it will produce a salt and a hydrogen gas. For example, if I am taking HCl acid, HCl is an acid. And if it is treated with sodium metal, it will produce a salt of formula NaCl and the hydrogen gas will be evolved out. Okay, this is an example. So the balanced reaction will be 2HCl. So we will have 2 NaCl and 2 Na. Okay. So if an acid is reacting with a metal, it will produce a salt and a hydrogen gas. Okay. And we have one more technique to check whether the compound is an acid or not. You see here. See this picture. If I am dipping a paper, you can able to see a paper, right? This paper is called as litmus paper. Okay. This paper is called as litmus paper and it is blue in color. If I dip the blue litmus paper into the acid, it will turn into red. If the solution is acid, the blue litmus will be converted to red color. If it is not changed to red color, then it is not an acid. Okay, the solution into which you have dipped the paper is not an acid. Got it? If it is changing to an acid, then the solution is, if it is changing to red color, it is an acid. Got it? If the litmus paper is getting changed from blue to red, it is an acid. And whereas we have this acid, we have HCl in the gastric juice inside the stomach, right? The gastric juice has HCl, it is an acid. And the vinegar contains acetic acid. Vinegar we have in our home, we use vinegar to preserve the pickles and all. Do you guys use vinegar in your home? I hope so. You might have used. Do you guys use vinegar at your home? Have you seen? Yeah. So that is actually the acetic acid. And the lemon. Lemon also contains an acid. Citric acid. Yeah. You might have studied about this acid in your class 10 also. Okay. Some detailed explanation will be here in class 11. So before moving on to that, I'm just giving you the basics. I'm just recalling the concepts. Okay. So lemon contains citric acid and tamarind contains tartaric acid. So these are some of the examples of acids. So from in the next class, I will go in detail about the acids. So I hope the topics which I have covered in today's session is clear for all of you. Am I right? Do you have any doubts from today's class? So today I have solved some PYQs of chemical equilibrium and we have started with ionic equilibrium. We have seen two types of substances and two types of electrolytes and the definition for electrolyte and some basic information about one of the electrolyte, which is an acid. Okay. So any doubt for anyone from today's topic? Any doubt for anyone from today's topic? No? Okay. So thank you all for listening to today's class. I have launched a poll. Please give the answers over there and then get ready for your next class. Okay, thank you so much, students. I have launched a poll. Kindly give your answers over there and then go for. Thank you. Thank you, everyone. Thank you. Bye. Take care. Thank you, my dear students. Thank you, Mahalakshmi.